is to actually sketch this out on a bigger sheet of paper. Okay, this is 9, this is 14 degrees, this is 35 degrees. I think y'all could probably fit everything on that page, but I'm going to do this. Now, the first thing I want to do is to figure out this angle up in here. Because I know that this is a straight line that adds, so the angles have to add up to be 180. So if I did 180 minus 14 minus 35, that's going to give me 131. Angle C is 131 degrees. So I'm given two sides of the included angle. So I'm given information for side angle side. So now I can use one of those two methods that I just talked about over here with law of cosines, actually this method right here. So the first thing I'm going to do is find the missing side using the law of cosines. So the missing side is side C. So C is going to equal 9 squared plus 13 squared minus 2 times 9 times 13 times the cosine of 131. So 9 squared plus 13 squared is 250. This is C squared. Sorry about that. C squared equals 250 minus 2 times 9 times 13, 234, cosine of 131. So you're going to take the square root. Now, normally when you take the square root, you want the positive and the negative value, but because I know that C is the length of a side of a triangle, C has to be positive. So C is going to be the positive square root here of 250 minus 234 cosine of 131. So C is approximately 20.09. Missing, yeah, the missing side. I don't know why that has a degrees there. That shouldn't have a degrees. That should just be 20. Once we figure out side C, then we can figure out angles A and B. And we had said that if we wanted to try to avoid those situations where there's two possible angle measures, then what we would want to do next is to find the angle opposite the shorter side. So we would want to find angle B because it's opposite 9. So when you find angle B, you're going to be using the law of sines. You would have 9 sine B equals 20.09 over sine of 131 degrees. Solve that and you get B to be approximately 20 degrees. And once you figure out this angle, then you can use the fact that the angles of a triangle add up to be 180 to figure out this angle, and this angle would be 29 degrees. All right, the next problem that we have is this with all of these circles on here. I'm going to switch from my marker to my pen for just a second. I'll be sure and write everything in Okay, I'm given these three sides correspond to centers A, B, and C respectively. So that means this goes in triangle A. So this side length is 5.4. So this side length here is 5.4. That's the radius. Angle or circle B has a radius of 4.5. That's 4.5. And this is 4.5. And then my smallest circle, circle C, has a radius of 3.4. So this is 3.4. This is 3.4. Now, this side of this triangle here is going to have a length of 8.8. This side of the triangle would be 7.9. And this side is 9.9. Now, if you want to, you can redraw your triangle if it helps to keep everything organized. We can redraw it over here to get rid of those circles, so I don't have to deal with those anymore. So now you see that you have a triangle where you know all three sides. So you've got side, side, side. So you would use the law of cosines, first of all, to find the angle opposite the longest side. If you have an obtuse angle, it's going to be opposite the longest side. I don't know that I have an obtuse angle, but if I do, it's going to be opposite the longest side. So I'm going to start off by finding the measure of angle C, and you're going to get C to be approximately 72.49 degrees. So once you know that, then you need to find either one of these other two angles. It doesn't matter which one. I think what I did was I found B. So I got B to be approximately 58 degrees. And then my third angle, A, was 50 degrees. And one of the things I don't think that I've stressed enough with this is that once you get all of your angles and all of your sides in all of these problems that we're doing in this chapter in section 4.1 with law of sines and 4.2 with law of cosines, go back and be sure your shortest side is opposite your smallest angle. Longest side should be opposite your biggest angle. Okay. Now, my next problem using the law of cosines here. The three given points are the vertices of a triangle. Solve the triangle, rounding the lengths to the nearest tenth, angle measures to the nearest degree. So the first thing I'm going to do is to sketch this out. And my marker bled through on my paper, so I'm just going to get a blank paper here to start over. I've got the point 0, 0, -2, 4, and 2, -1. So I've got an obtuse triangle here. This was A, this was B, and this was C. So I think this problem is interesting because they just give you those three vertices. They give you no information about the angles. or the side lengths. So you have to figure something out. Well, the only thing that I know to do from here is to find the side lengths. I can't figure out the angles because I don't know any sides. So I need to figure out the side length of AB here by looking at the distance formula or drawing in that right triangle and using the Pythagorean theorem. So your distance formula is based on the Pythagorean theorem, so it doesn't really matter which way you do this problem. What did I do? I think I did a right triangle from here. So this length is 2. This length here is 4. So this is side C because it's opposite angle C. So I'm going to figure out the length of this by taking the square root of 2 squared plus 4 squared, right? Use Pythagorean theorem. And you're going to get the square root of 20. Now, normally in college algebra, when we see square root of 20, we want to simplify that and say, okay, 20 can be broke up into 4 times 5 because 4 is a perfect square, and then simplify that to get 2 times the square root of 5. But I don't need to do that here on this problem. So let's just leave it like that for right now, and we'll go on to find side A. Let's see if I can draw in my right triangle here for side A. So the height of this triangle is 5, and this horizontal length up here would be 4. So to figure out A, I'm going to have the square root of 4 squared plus 5 squared, that's 25, and 16, that's 41. 16 and 25, yeah, I believe that's 41. Then my other side is side B, and that would be 2 and 1 for that, for the legs of that triangle. So 2 squared plus 1 squared, that would be square root of 5. Okay, so now I know the lengths of all 3 sides. So my next step here is to use the law of cosines to find the angle opposite the longest side. So the longest side here is the square root of 41. This is one of those examples where it really kind of pays to know what's coming next, to know that I don't really need to round these, because I know that when I'm using the law of cosines, I'm going to have like a squared equals b squared plus c squared, and then the rest of that thing with the cosine in it. So on this problem, I would have the square root of 41 squared equals the square root of 5 squared plus the square root of 20 squared, and I'm running out of room, minus 2 times the square root of 5 times the square root of 20 cosine A. So when I simplify this, the squares and square roots are inverses. they cancel out. So I end up with 41 equals 5 and 20 is 25. This is square root of 100, which is 10. 2 times 10 is 20. Cosine of A, subtract 25 from both sides. You get 16. And then divide, so cosine of A equals negative 16 over 20. And then you can stick this into your calculator and figure out the measure of angle A. I did this right. So inverse cosine of negative 16 divided by 20. So you get 143 degrees. And my picture is not perfect, but it's accurate enough to see that this is an obtuse angle. And that's what I have here is an obtuse angle. And I know that then my other two angles are going to be acute angles. So I can use the law of sines to figure out one of the other missing angles. And then the third angle I would find by doing 180 minus the other two. No, the fact that the angles have to add up to be 180.